Are you a coder who gets rejected based on no practical experience or because others have a strong LinkedIn personal brand and you don't? Your coaching institute will hate me for doing this, but I welcome you to Code to Career 30 days challenge where I have chosen these 5 total strangers out of my LinkedIn contacts and have taken up the challenge to help them go from jobless or underpaid to well paid job, that too without additional degrees and certifications in the next 30 days. If you are a coder and wants to get a well paid job, this is your golden chance to experience real project implementation from scratch that gets you a well paid job and builds your LinkedIn personal brand and also resume for absolutely free. So why just watch? Get into our WhatsApp community to experience this. Link is in the description. Now let's get started. Yes, any questions till now? The complete process of TFTP server from the minimal server of and client interaction and adding one by one service, the read request, the write request, then the acknowledgement, the data, the error conditions. Then we also discussed about the optional acknowledgements, and we also saw how the optional acknowledgements with respect to negotiation of the payload, the file size, the timeout, everything. Any questions that you had? Yes. How are you?
I'm good, sir.
Yes. So any questions?
Not exactly, but the only thing I was thinking that why do we exactly need, yeah, exactly use rate limiting? Like,
Huh? Okay, the rate limiting.
yes.
Rate limiting with respect to the server to decide that okay, I will only accept these many connections or
But
these
why is
many
it? But
packets.
why is it necessary, or is it necessary or not?
No, no, it is not question of whether it is necessary or not. It is an indicative of that a properly behaving client will not behave in that way.
Okay.
See, a client will not do a nasty job of creating so many clones out of it and make so many connection requests or so many things that the server gets overwhelmed. So that's the reason why when I know that in a typical environment that this particular communication has to happen and there are only 2 or 3 transactions or 2 servers, but if I see too many connections coming in, so I have to rate limit. So it's a security measure rather than asking whether client, why is the server doing it? It's more of it, the server doing it to ensure that genuine clients are not deprived.
Okay.
So you're doing that OTA application, right? You are developing some OTA application.
Mhm.
Let us say that the end device which is supposed to get the latest version of software and some intermediary module which accepts connection and then takes up all the binary file and finally create the checksum or verify the binary and then put it into a device. Let us say it is getting 30 to more than 10 or more than 2, or in this case, I would say even more than 2 requests saying that, okay, this is the binary file, this is the binary file, then I should suspect, right? Did you get the point?
Yes, yes. Got it.
Yeah. Okay, today let us start with, let me open the PDF and keep it ready. We will talk with respect to So this actually answers one of the questions that were asked earlier with respect to the usage of the system call, the select system call versus fork. So the select system call is a single threaded thing. and a fork is a different kind of mechanism where I make a clone of the same process and I do it. It's entirely a different process. Select is for one process. Clone is creating multiple processes. But now we are going to see that within one process, instead of a single thread of execution, how can we leverage the threading model to actually handle different requests? Could be read request, could be write request, data, or anything. Typically, we will be handling only read and write request because each independent read and write request has its own transactions happening in terms of acknowledgement in some of data packet. So if I handle read and write requests as two separate threads, I am more than good to have a well-behaving server which is handling clients. For every operation, it is creating threads that will handle the read request and the write request. And the read request and write request can be independent, and there can be any number of read request and write request threads that I can create because each transaction is uniquely identified by the TID. Till now, is there any question? Is this clear?
Yep.
Okay, so this is what is the introduction to the multi-threaded server. So the reason is multi-threading allows server to handle multiple clients simultaneously. Yes, not exactly simultaneously, but we know that it actually switches across these threads, increasing efficiency and responsiveness. Each client, and the reason is also because we can have a priority of the thread that something can be scheduled immediately. So in that way, responsiveness is already taken care. Each client interaction can be handled in a separate thread, ensuring that the server can continue to accept and process new requests even while waiting for IO operations to complete with other clients. So the threading model is very simple here. Let us directly jump to the code and we can talk about the challenges. Only two threads we are going to create, but in this program, it's only one thread. The library is the pthread library. I would be sharing one document to you. It's one of the best documents. If you want to work with me personally, where I guarantee to work with you until you secure a well-paid job, book a one-on-one call with me. Link is in the description. There are so many books, so much material you will get when you Google for this thread library, pthread, also POSIX thread, also called as pthread. You will end up with a lot of things. There are some famous books also that are written and everything is present. But this is one document, something like a Bee's guide that I have mentioned, will give an initial understanding and initial way to actually, or I should say the initial platform, the footboarding with respect to pthreads. So I will be sharing it in the group. So let's get to this is the function that gets triggered when the server gets created. So there is a similarity between the thread that we are talking about, so-called the construct called thread, and also task. Typically, the task is a RTOS kind of environment terminology, and thread is more like a OS, which is a generic OS or which has user space and kernel space and all that stuff. There can be threads at the kernel level and there can be threads at the user space level. Now we are talking about the threads which are at the user space. So whenever a thread gets executed and created, there will be some function that can be called. That function to handle client requests. So I need to essentially associate a thread with its unique functionality so that the thread should know that once I am created, what is that I need to do. So opcode, we are getting the opcode. Then we are seeing whether it is a read request or write request or default is unsupported operation received. We are closing the socket and we are coming back. So this thread is handling per one, this function is handling per one thread these operations, which is the server responding to one particular client. Here we create the standard stuff, socket, setting up the socket, binding the addresses and all those things to the socket and start listening. Now here is a thread operation starting. Now the thread is given its own space of data. I mean, it's given its own socket FD, but it is not any global thing. It is unique to that thread. And how is that happening? When I am creating the thread, the popular API is pthread create. I am associating this thread with this socket FD. That's why I am using a malloc, so that whenever I have a request coming in, I can malloc separately. It is an individual piece of memory or a separate piece of memory from other things. And I associate that particular socket FD with this thread. So this is a pthread detach API. I'm not going to get into the individual pthread functions. That is where I'm going to give you that document, which has not much explanation about pthread detach, but a little bit of saying about it. But yes, this operation it allows the thread to free its resources upon completion. Now there is one point that I want to mention here. When I create a thread, then I am interested to know what is happening to that thread. So typically I say pthread join to really take care of what is happening to the thread, and if there is any, not if there is any, if the thread really concludes its operation, I am interested to know whether the thread has ended properly, in the sense the function which is called in the thread, whether it executed properly or not. But when you say pthread detach, the server is no more worried about that thread. There is nobody to actually take care of that thread in one sense. So we are using that functionality because the server is busy accepting connections from client. Any questions so far?
I have a question, but it's not directly related to what we are studying. But the how does the thread mainly works? It's related to that. So every time we populate a new thread, does it have its own stack, its own heap? Does it work like that? And when we free it, is it like when we free the malloc? When we use the free function for freeing up the heap, or
See, the thread typically, the
is it
thread
something like
depending on the
there's
OS, typically in Unix environment, threads
something
are
different?
those. Yeah, I got your question. So in Linux environment, typically the threads, they share the same stack. That is the understanding. They share the same address space of the process. So there is a distinction between this process and thread. Thread is one unit of execution. That is true, but it shares the whatever the stack or essentially the address space of a process. But the process are two different entities where each has its own address space. Typically, the threads within a process share the same address space of the process. Yeah.
Got it.
Okay.
So process share the thread share the address space of the process, right?
Yes. Yeah. See, essentially, this is all I would say alphabetic soup. People say that if you have this even popular statement, you will also find it on internet, or if you Google, you will find it saying that threads are called lightweight processes. It actually doesn't make any sense. Like for example, somebody will say um, virtual memory. How can memory be really virtual? Because virtual is virtual, right? It's not existing. But memory is something very concrete. Virtual address, I understand that as of now it is not existing, but it will be mapped to some physical address. We know that. But virtual memory, still people use that. In the same way, threads are called lightweight processes. But thread is not a process. They are calling lightweight process only because maybe they don't have so much of overhead when a process really does when a context which really happens, and instead of process A, process B has to be scheduled, then I have to do a lot of housekeeping of taking a snapshot of that context of the process, save it somewhere, schedule the other thread, pull its context. You're getting the point? For thread, I don't have to do that.
Understood.
Yeah.
So how does, if the context switching doesn't happen, it happen like we have for processes? How does it happen here? Don't we take
See,
snapshots
when
or?
a context switch has to happen, processes, it's the process that will get context. In the context switch, it's actually the process only. But for thread, there is nothing like
Hmm.
context switch
Okay.
because it's looking at the same address space where the stack variable. It is just that I am splitting the task into individual pieces that can be easily put onto the CPU to execute. But when it wants to access some memory, it would be the memory of the process only. Yeah.
Once one doubt, so can we say like in RTOS we have tasks, right?
Hmm.
So something like in general GPUs, can we say it is equivalent to processes? I mean, can they be equated? Equivalence is valid.
Yeah, task can be equated to process, but few people even equate task to threads also. Even though
No.
even though it is not strictly valid in the sense that a thread is sharing the same address space, but if you have a task has its own set of registers, and I take a snapshot of it and I store it. Then when another task comes, the new task or the task which is now scheduled, its particular context switching or task control block will be accessed. But
Right.
but there is not so much overhead with respect to what a process actually entails. And see, uh, if you really want me to say one statement, this all complexity comes because of the complexity of the underlying OS and how it maintains a lot of this virtual addresses. It has to maintain a lot of files that are open. Many things happen with respect to certain work to happen. Certain work has to happen. Then I may have to open a lot of files. Now, when I'm really doing a context switch, it's a very intensive. That's why if you go and look at the task struct or whatever the structure that is defined for this defining a task, right, in a Linux kernel or something, it will be very huge. And imagine storing all this at one place and bringing the new thing again and loading it into registers and making the other thing ready. It's a very big task, big amount of work on behalf of the processor. Yeah.
Sure, Vamsi.
Yeah, so
If you
the
have
full
any
end of the
resources
code.
like to say,
Sorry,
if you have any resource like which can compare process threads, etc., then please do share that also if you have so.
any resource to compare. See, there isn't anything like comparison of as that, and that is why I'm to say I want to say again that these terminology may change tomorrow. Within RTOS also, somebody who writes the kernel may decide to say the task as thread. There is something called as threadx. Now, free RTOS calls it as task, and MuCos also calls it as task. But I don't know, maybe threadx might be calling it as thread,
Okay.
but the functionality is same. You have a working program or a working flow of instructions. Somebody wants to grab the attention of the CPU. A snapshot of this working program is taken, stored into memory. The previously taken snapshot of the newly coming process will be restored and it starts executing from that point. Even if you ask me, when in a simple while one loop, when you have a bare metal code running, let us say this simple while one loop is just blinking the LED. Yeah. The moment I press a button, the LED blinking has to stop and LED has to either switch on or switch off. First time I press, it has to switch on constantly without any blinking. The another time I press, it has to switch off. Now, this is a different behavior. Imagine for a moment if the processor is not disturbed, which means there is no button press. Yeah. Now, what happens? If there is no button press, the processor is happy blinking the LED, right? Are you with me?
Yes.
Now, the moment I press the button, interrupt comes. Now interrupt is something which is disturbing processor from what it is doing without any disturbance. If you that time want to work with me personally, where I guarantee to work with you until you secure a well-paid job, book a one-on-one call with me. Link is in the description. If you see even an 8-bit controller to a high-end controller, you will push all the registers, you will go to the interrupt service routine, execute the interrupt service routine, come back, and before coming back, pop all the registers and then start executing. How many of you are aware of this thing? How many of you are aware of this thing that happens?
Yes, sir.
Yeah. It is just that we don't know that processor is doing all those things. And we have, for us, only one instruction called IRET or something, right? Some controllers will have only one instruction which will enable the moment you call IRET, it's a written from the interrupt, but in the back end, all the registers are already restored, which is not transparent to us, or which is actually transparent to us. So this always happens, even in interrupt service routine. So typically typically how I see is interrupt is something that comes without any warning or any indication that I am coming. But when you want to do a task context switch or something, you explicitly create certain stimulus or certain condition because of which the task can switch. Yes, there may be situations, or most of the time there are situations which are doing that, which are making one task to go away, but another task to come into the scheduler. But there is a predictability, like which task is coming, which task is not coming. But for an interrupt service routine, there is no predictability. But the operation, in the sense, the impact that these both create on the controller is same. Either restoring or, saving the context and restoring the context at the basic level. There can be many things more than that. Yeah.
Okay. Yeah.
Okay. So this functionality is very simple. Thread creation. Each incoming client will have a pthread create. Resource management. New sockfd is dynamically allocated to pass the socket file system safely to the thread. The thread frees this memory to avoid leaks. Thread lifecycle using pthread detach allows each thread to clean up after itself once completed, preventing resource buildup. So forget about the assignment. You can do it later. Now the most important thing is this one, which is the topic of discussion today called service-oriented architecture. Now, service-oriented architecture says these fundamental things. If you understand these things, then you are more or less, see, it's a very, very complex topic. It is used at large scale enterprise software, but the fundamentals are almost same. It is because the devil is always in the details, and the services that are given to the clients, or the services that an enterprise enterprise grade software actually has, are many, many services, innumerable services, but the fundamentals are same, that each operation or the complete orchestration of all these kind of, for a particular action to happen, there are various services that talk with each other and share data with each other. The beauty of service-oriented architecture is each service is loosely coupled with other service, and it talks with other service by sending messages. And each service can be easily developed by itself. It can be deployed, it can be removed, and all those things can be done. Because when a service has to talk with another service, let us say service A is talking with service B. You can think of layers also. You can think of TCP/IP layer providing the IP layer giving IP service, the transport layer giving transport service. The transport service layer, if at all the lower level layer has to talk with it, or the transport protocol layer has to talk with IP layer, there are well-defined APIs that are created. Now these services, in the modern day, I can think it of a REST API, I can think it of anything. The point is, once the interface is fixed, for a particular service, how I implement the backend service now becomes immaterial. For a client, it doesn't really need to know how the server has actually is storing the files, in which file system and all those things. As long as its interface to the server in the way that it has to communicate and request for a file is not changed, the client really need not have to worry about how or what file system is the server actually using. Are you people getting this point? Any question here? Okay, I take your silence as that you understood. Now, how do we implement? So TFTP protocol, we know this, it has read request, it has write request, data, acknowledgement, and error. Now, implementing service-oriented architecture for TFTP means that you have to identify the services required. So there are these 4 services that are defined. Request handler service, in the sense whether it can be a write request or a read request. Data transfer, because it handles specifically the data and associated acknowledgements with the data. Error handling, specifically to handle error kind of packets, which is opcode number 5. And file management service, which is to take care of the reading and writing of files on the server. It's not the request, but actually manipulating the files that are there on the server. Either creation of a file or file permissions, everything and anything that has to deal with the file management. Now, how is the service interfaces created? So this is one of the representations. And we use here the concept of function pointers. How the handle request has to be done, I am not defining. I am only defining that in case somebody has to define a handle request, let us say for write or read, this is the typical signature of the interface, that the function will accept socket descriptor, it needs an address of the client, and it needs a buffer, either to write back the data or read the data. Then the data transfer instructions. Either I send the data or I receive the data. Now the data can be pure data or it can be even acknowledgement. I am not defining. But if at all I have to assign a particular function to this function pointer, I better ensure that these are the parameters that are given as part of the function. Now error handling also same. I can put any handler. Depending on the kind of error, I can take any kind of action, but it has to enable or it has to have these kind of parameters as part of it. Similar for management, because we told that open the file, read file, write file. Now, how do we implement? Let us see this one example. The other examples are similar to what we are doing. So I define a function called handle request. For simplicity, I have maintained the name of the function also as the name of the function pointer. So I'm saying that this function is getting these parameters, sockfd, address, character buffer. This is the operation that I am doing. It could be anything. Pass the request and determine the type, whether it is RRQ or WRQ, call appropriate handler functions from data transfer service and file management service. This is important. So what is happening here is, once in this handler, if I am doing this bifurcation, whether it is a read request or write request, I am calling the handlers from the data transfer service and file management service, because those operations have been separately categorized as services which are providing well-defined operations, which is here send data or receive data. So typically what is happening is that I am not doing everything at my side. Rather, I am calling a service provider. Think of like this, that in a service-oriented architecture, how you have an issue with in your house with respect to plumbing or electrical work or anything that you call a service provider. You want to have an internet, you go to a service provider. Think of all the services as being service providers of one service or the other. When I want to have a particular service to be completed or a particular action has to be completed, I make use of one service which internally can make use of multiple services to solve that particular action. Similar way, I have this function. If you want to work with me personally, where I guarantee to work with you until you secure a well-paid job, book a one-on-one call with me. Link is in the description. Which I am setting it to. I have a receive data and receive data and send data, which I am setting it to these function pointers. Similar for error handling implementation, file management implementation. Now let us integrate the services and see how a typical TFTP server can grow and seamlessly handle these particular services to help the user do either a file transfer or write into the server or read from the server. Standard thing, starting the server, bind, we are receiving. Now we are calling the handle request. Now which service, which is the thing that I have to create into a service, and which service internally will call the APIs or the service points, service access points of another service, is something that the user can decide. In our case, if I am handling the request and internally the handle request is calling different services of, different service access points of other services, it's a decision that I have taken. Is this point clear? There isn't much difference here, and we cannot see the power of service-oriented architecture in this small example. What I am trying to do actually is a desperate attempt to actually to bring in front of you the capability of service-oriented architecture. But to be very honest, this trivial application cannot really bring the beauty and the profoundness or the capability of service-oriented architecture. But if you get into a very complex environment and a complex way of doing the things, your service-oriented architecture actually shines. Because imagine, if a Windows PC has to talk with a Linux PC, and they are like, you want to do a file transfer, and a Windows PC has to talk with a Linux server or something, and there are many services with respect to the server saying that it has to encrypt the data and all those things, and those services are located, let us say, in another Windows machine. A big enterprise software, or let us say the email server of an office, or file transfer file repository of an office, or the payroll management system. Imagine a payroll management system wherein it is centralized located and it is holding all the payroll details of a person. Now somebody is working remote and that person puts down the paper, and today is his last day. So his payment management system has to make a record that this person is now no more an employee. And to know that this person is no more an employee, the payment management system has to, every month, let us say the payment management system has to deposit the salary as per the person's eligibility. Now the computation of salary will be done in one server. Now that server will ask another leave management server with so many other details. When there is so many systems interacting with each other, saying that whether how many leaves that person has, whether the tax has been computed or not, is that person working or not. Can you see the so much of information going here and there? I am talking about one person leaving a job. What about so many people joining the company on the same day? So many people leaving the company on the same day. So much of information is getting transferred here and there, and each services can be maintained in its own server. And some engineers would have taken decision of running something on Windows, running something on Linux, running something on some other software, whatever, I don't know. Somebody might purchase a different application, somebody might purchase a different payroll management software. When all these complex things are going here and there, up and down, service oriented architecture actually shines, because the payroll management software doesn't have to really worry about how the leave management service has been implemented. It just needs to know, if I send this API with employee number, name, date of joining or something, the payroll management will send me the relevant data in a format that I understand. Is this now making sense? Is this
If
clear now?
I've gotten you correctly, it is mainly designed around clean interfaces. So what you are going to expose,
It's
uh,
you can start, your study of service oriented architecture by understanding that it is based on clean interfaces, but it is much more beyond that than that. You will get literature that will really put you confused, in a confused state. There are books that are 400 to 500 pages written exclusively on service oriented architectures. At a beginning level, yes, clean interfaces and well-defined interfaces of a service, so that the other service which is trying to access service A's help uses the well-defined interfaces. If you are with that, if you got that done, you are at good level. Because
okay, so
yeah,
where would you like us to go to the next step? I mean, what should we study after we understand the clean interfaces thing? What exactly we should look for next?
see, at a minimum level, when you are writing a software, when you don't know going forward your one functionality, let us say you wrote a very complex algorithm, not complex algorithm, let us say some way of manipulating the data of certain parameter, a very important parameter, and it has been written taking into consideration lot of variables and other things. A little bit of complexity is there in that implementation. Now you say that it makes no sense to for people to repeat this logic everywhere. My software, my function is well written. It is just in C or C++ or whatever language. The logic is perfect. It is working under all conditions, tested. Now, when somebody has to use this service, let us say you wrote an encryption library. You did all the complex mathematics of encrypting that particular data. Now, what's fun is it for the company to write this complex logic or replicate it everywhere in every other place, in whichever project it is doing? They can use your code as a library or whatever, right? Let us say it has been proven to be very well working in so many situations. Then a software which has nothing to do with your embedded work, or which has nothing to do with any kind of firmware or user application, but a very remote or not at all relevant thing, they came to know that this is something that can be used. I'm talking about a very hypothetical situation. In such cases, if you convert your particular code as a service that is given by a server, and you say that this is a well-defined interface, and if you use this interface, you can make use of my services. This is one of the classical example. Now, how is it possible? How is this possible? You will be witnessing that how service-oriented architecture is very much being used in adaptive AutoSAR. And I will say after this session, I will tell you. But the point I'm trying to drive home here is, I can tell you I gave you an example of payroll systems and other things, and why one system has to interact with other system because of its necessity. Every time I go an upgradation of this payroll software, and if it is and if it's let us say its upgradation is something which is changing the way that the other entity has to talk with it, then the system is broken. For example, let us say the payroll system says that you have to talk with me in XYZ way. Now, that XYZ way, if it is static, but the backend thing is changing, I have no problem. But if I go for a what should I say? Re-implementation of my payroll thing, but somebody says that no, because we are implementing afresh, the XYZ has to be replaced by ABC. Whichever are the servers that are depending on, whichever are the other systems that are depending on XYZ, they also have to undergo a change. Are you getting the point? So essentially, these services which are independent in themselves are loosely coupled so that change in one thing does not affect a change or does not create a change in the other. And I'm telling you again, this small piece of code and the kind of small pieces of code that we deal with, and typically in embedded world with respect to firmware and all those things that we are writing, maybe to a product, even though the number of files might be hundreds, will not really showcase us the power of service-oriented architecture. But if you really look at a very complex enterprise architecture and complex enterprise where there are thousands of employees or lakhs of employees and their all data has to be stored and each data has its own way of structuring, and there are so many services that are associated with one employee, or forget about all those things, even people who has to punch in a number, punch their card and get inside. The server has to check whether the person is a genuine person or not to give the access. Why is that? The card is not changed. The card is still same. But whenever I punch it, if at all I am no more an employee, the indication will be red, which means the server which is giving me access, somewhere it went and tried to find out whether this person is currently employed or not. The return value will be false. Then it is not allowing. But this mechanism of talking with the other service, which is whether the employee is present or not, or he is employee or not, is not so easy because every employee. If you want to work with me personally, where I guarantee to work with you until you secure a well paid job, book a one on one call with me. Link is in the description. Or the database which contains all the employees and this access server, it has to contact every time. It's not a small thing that is happening. So I cannot now bring that heavy thing and put on your head and in a very way, in a way that I make you realize that, oh, okay, is this what you are saying? Because the example that we have talked about is very, very trivial. In fact, I would say for these kind of implementations, like a trivial file transfer protocol kind of implementations, we should never even restore to a complex architecture like service-oriented architecture because it doesn't fit. Yeah. It is like to plant a small sapling, I brought a big crane now. I can as well use my hands. But I brought a crane to show you that, boss, there is a crane. Tomorrow, when you want to uproot a tree, you can't do it by hand. You need a crane. But understanding that there is a crane existing is important, right? So that when you see a tree, a problem like tree, you know that you have to use crane. You can't use your hands. Yeah. So that is it. If there are no questions, I think we are good with it. I will be sharing with you the document, which is the pthread document, very well written. It has also got a GitHub repository with lot of code in it. So you can practice that code also. You will understand how the code is working. But these are two powerful things. You mentioned that I know pthread, and you mentioned I know service-oriented architecture, and you do a decent amount of study on service-oriented architecture. Try to implement something on your own. I can say in automotive domain, if you are trying to get a job, people are looking for resources who knows service-oriented architecture, because adaptive AutoSAR is slowly coming up. Just I Googled actually in my first connections to really understand if I can, because my friend who told that he wants to come, but he's busy with thing. I was not able to find anyone who can talk about adaptive AutoSAR. Very few people. Very, very few people. Because you need to know C++, there are many, many things. You will come to know about it. Yeah, please go ahead, start implementing the code, write on your own, get an understanding of these concepts, recap everything that you have done till now, the use case diagram, the sequence diagrams, write the essay, the concept of test driven development. All these things are various tools I try to equip you with in the short span of 30 days. And the last session will not be it will not be anything about TFTP. It will not be anything about the proper stuff that is related to TFTP. It's all about you are having the code. How can you port it onto your own platform, your custom platform? Maybe based on ARM tomorrow, then tomorrow any other controller. So that's all about. And typically that small kernel, which is stripped down, might not be having so many file system support, supporting only your controller, might not be having so many drivers, might not be having so many other stuff. And that stripped down version is what people call embedded Linux, because it has been stripped down, but the kernel proper will be there. And you want to add this application on top of it. So you need to compile the application as per the controller using a different tool chain and all those stuff. So that would be the last session. And we would be meeting on Wednesday. Yeah. Any questions for the things that we have done now? Anirudh, Chandrika, Harsha, Snehal, Swaminathan, Yash. No. Okay. So let me stop recording. Where is this?